Good morning. Today, I'd like to have some more of these trig integrals. Previously, we looked at integrals of powers of sine x times powers of cosine x. Today, we'll do the same, except instead of sine and cosine, we'll have secant and tangent. Just as with the first category, though, there are certain facts that will help us out. If you take the identity cosine squared x plus sine squared x and divide through by cosine squared x, you find out that 1 plus tangent squared is secant squared. That can be rearranged to tangent squared is secant squared x minus 1. We also know what the derivative of the tangent, the derivative of the secant, and the integral of tangent x dx, integral secant x dx are from the first semester. The first of our new rules has to do with the integral of tangent of x to the n power times secant of x to the m power with respect to x. The first recipe is, what if the power on the secant is an even positive integer, an even positive whole number? The suggested recipe is to do this. Split off a factor of secant squared x and group it with the dx. In what remains, if the secant factors were not there, you could just do a u substitution using u equal tangent of x. The key point here, though, is if m is even and I remove two factors of secant x, I still have an even power of secant x there. I can use my trig identities to turn that into tangent x's and then carry out the u substitution. As an example, let's think about the integral of tangent to the fourth power secant to the fourth power dx. The first thing that I should lock in on is that even positive power on the secant. I'm going to do as suggested and split two factors of secant off. As we just explained, if this factor were not here, I just do a u substitution where u is equal tangent of x. I'm going to use my trig identities to express this factor in terms of tangent, and then I should be able to do the integral fairly easily with the u substitution. I'll write secant squared of x as 1 plus tangent squared of x. The parentheses are necessary. Then I'll let u equal tangent of x. This is the integral of u to the fourth power times 1 plus u squared. If u is tangent x, du dx is secant squared x, and du is secant squared x dx, which is why I wanted to split that secant squared off in the first place. This turns the integral into this, which is that, which is easy to do. And then you recall that u is just tangent of x, and you have your result. So this is the first of our new techniques. The power on the secant is an even positive whole number. Next, if the power on the tangent is an odd positive integer, then here's what you should do. Split off a factor of tangent x secant x and write it besides the dx. The reason that this is going to work is I may have some leftover factors of secant there, but if the power on the tangent was an odd positive whole number, when I split one of those factors out, I'll have remaining an even positive whole number, and then I can use that to express this tangent in terms of secants, and then I should be able to do the integral with the substitution. For example, let's look at the integral of tangent cubed x secant cubed x dx. The even power on the secant idea is not going to work here because that's not what I have. On the other hand, the power on the tangent is an odd positive number. I'll follow this suggested procedure and factor out a tangent x secant x and group it with the dx. In what's left, I used to have 3 factors of secant x. Now I have 2. I used to have 3 factors of tangent x. Now I have 2. But one of our trig identities says tangent squared of x is secant squared of x minus 1. So I'll write this tangent squared in that format. My integral now is the integral of some stuff that only has secant of x in it, tangent x secant x dx, and since the derivative of secant is tangent secant, I should be able to do this with a u substitution. I'll let u equal secant of x. Du dx is secant x tangent x. So du is secant x tangent x dx. If I write my integral using these facts, here I'll have a factor of u squared minus 1. Here I'll have a factor of u squared, and tangent x times secant x dx is du. This turns this into a very easy integral to do. U squared minus 1 times u squared is u squared times u squared minus 1 times u squared. This is a polynomial, which is easy to integrate, and then I remember that u is short for secant of x, and here is my answer for this problem. In this integral, I don't have any factors of tangent x at all, but I do have an even number of factors of secant, positive even number. So I'm going to try our first technique again. I'm going to see about splitting off 2 factors of secant x. At first glance, it's not clear what I should do about that secant to the 4th power, but then I realize that the 4th power of something is the square of the square of something, and that secant squared x is 1 plus tangent squared x. In this part of the integral, there's nothing but tangent of x's. The derivative of tangent x is secant squared, so this suggests an obvious substitution. At this stage, hopefully everyone can see that this integral is easy to do. An antiderivative will be u plus 2/3 u cubed plus 1/5 u to the 5th power, and then you remember that u equals tangent of x, and you have your result. A similar procedure can be followed if you have the integral of tangent x raised to an odd positive power. The last of the commonly seen variations on a theme in the tangent secant arena is when you have an integral of a power of secant x with the power being an odd positive integer. The split off the secant squared thing by itself won't work, but something very similar to it will if we think about integration by parts. In this integral, I have 3 factors of secant x and a kind of sort of factor of dx. That means there's quite a few different ways I could split this up into integral of u dv, but I'm going to do this. I'm going to let u equal secant x, and I'm going to let dv be secant squared x dx. The du is going to cause me some trouble, but the v will be relatively nice. If u is secant x, derivative of u is secant x tangent x, du is secant x tangent x dx. That's a little bit troubling because the du looks more complicated than the original u. But to press on, if I pick the dv to be secant squared x dx, the derivative of v is secant squared. V must be an antiderivative of secant squared x. V must be tangent x. I'll write out the integration by parts formula next. The integral of secant cubed x must be u times v minus integral of v du. V is tangent x. Then I'll have another factor of tangent x, then secant, and then dx. This integral is this quantity minus that integral. At first glance, it looks like this is not going anywhere, but I have a trig identity involving tangent squared of x. Maybe if I take advantage of that, we can see something. So moving this term over to the other side, I get 2 integral secant cubed x dx is secant x tangent of x plus the integral of secant x dx, which from our list is natural log absolute value tangent x plus secant x, and I should add on a constant. I'm going to write my constant in kind of a funny way. I'm going to write it as 2 times some other constant for reasons that will become obvious in the next comment. Divide through by 2. I think most people would agree that out of all of these tangent x, secant x integrals, the worst one is when you just have a power of secant x that is an odd positive whole number, because you have to do integration by parts on it. This has been a discussion of the second category of integrals involving trig functions that are frequently seen. I hope everybody has a good night. I'll talk to you again soon.